In this example, we're dealing with the combustion of glucose that takes place in the body. And the question is, if we start with 1.2 kilograms of glucose and burn it all, how many grams of water are produced? Well, this is a stoichiometry problem. You know it's stoichiometry because you're being asked to relate mass of one substance to mass of another substance. About the only way you can relate the amount of one substance to the amount of another substance is through stoichiometry. We have a balanced chemical equation, so we can get started. As is the case with all stoichiometry problems, we can't work with the chemical equation until we get into moles. So our first job is to take the mass of glucose and convert it into moles. Well, we immediately see a problem. The only way I know to get from mass to moles is by using grams. We don't have grams of glucose here, we have kilograms. So the first thing I have to do is convert kilograms to grams. I'm going to assume you know how to do that by now. So 1.2 kilograms converts to 1.2 times 10 to the third grams. Now I can finally get to moles of glucose. To do that, we look at the periodic chart. Here are the entries for C, H, and O. To get the mass of glucose, then, we take 6 times 12.0 for the 6 carbon atoms, plus 12 times 1.01 for the 12 hydrogen atoms, plus 6 times 16.0 for the 6 oxygen atoms. When I add this together, using the rules of significant figures for addition, I get 180.1 AMUs. Now that also tells us that 1 mole of C6H12O6 is equal to 180.1 grams of C6H12O6, and now we can convert to moles. So we take the number we know, 1.2 times 10 to the third grams of C6H12O6, we put it over 1, and we multiply by the conversion relationship with grams of C6H12O6 on the bottom so that they cancel. When we multiply through, we get 6.7 moles of C6H12O6. That's the number of moles of C6H12O6 that are being burned. We can relate that to the number of moles of water being produced. This relationship comes from the chemical equation. If we look at the chemical equation, the coefficient next to C6H12O6 is blank, so that means it's 1. And the coefficient next to water is 6. So that tells us that 1 mole of C6H12O6 is equal to 6 moles of H2O. That gives us a conversion relationship. So now we convert. We take 6.7 moles of C6H12O6, we put it over 1, and then we multiply by the conversion relationship. Moles of C6H12O6 is going to go on the bottom so that they cancel. That leaves moles of H2O on the top. So when I multiply through, I get 40 moles of H2O. Now the problem is I need two significant figures here because 6.7 has two significant figures. So I'll have to express 40 as 4.0 times 10 to the 1. That's the only way I can make that 0 significant. Alright, well that's actually an answer to the question how much water is produced. 40 moles tells you how much water. Unfortunately, the mean guy who wrote this problem wants the answer in grams, not moles. So we'll have to convert from moles to grams. You should be an expert at that by now. The entries for H and O on the periodic chart are there above. H has a mass of 1.01, O has a mass of 16. So H2O has a mass of 18.0 AMUs once you account for significant figures. So that tells us that 1 mole of H2O is 18.0 grams of H2O. So now we can convert. We take the number we know, 40 moles of H2O, we put it over 1. Then we multiply by the conversion relationship. We need moles of H2O on the bottom so that they cancel. And so then when you multiply through, you get your answer, 7.2 times 10 to the 2 grams of water.